Compressed air foam systems, or CAFS, offer a number of safety features including a longer stream reach. Firefighters also experience less fatigue because of a lighter hose and a faster fire knockdown rate. The more uniform bubble structure provides longer-lasting foam bubbles that resist heat longer and offer better foam adhesion. The CAFS system is rated to provide 140 CFM capacity for generating compressed air foam. This is enough for 3, 1 3/4 inch discharges. The consistency of the compressed air foam is adjustable for each discharge, by how far the water valve is opened or closed. Remember, for structure fires, wetter is better. All CAFS discharges have a discharge valve control, an air injection control, and a discharge pressure gauge mounted on the operator's panel. Each CAFS discharge features a check valve, to prevent reverse flows of compressed air back into the water system. The three subsystems that make up a compressed air foam system are the water pump, the foam concentrate proportioner, and the air compressor. A water and foam solution is discharged through the discharge valve and the water check valve, eventually flowing out through the discharge hose. Air is injected after the discharge valve and is mixed in the hose. Air compressors generate a considerable amount of heat. To remove the heat from a rotary compressor, oil is used as a coolant. After the oil is separated from the air, the oil is ready for re-injection into the rotors. Before re-injection, the oil is cooled to remove the heat from the previous compression phase when the oil was passed through the rotors. The oil is passed out of the compressor through a thermostat valve to an oil-water-tight cooler. Water from the fire pump is circulated through the cooler to extract the heat from the oil. Hydraulically driven compressors have a dual cooler that also cools the oil used in the hydraulic drive system. The system cools both the oil that drives the compressor and the oil inside that lubricates the compressor. As for the strainer, frequency of inspection will ultimately be determined by amount of use and clarity of end-user's water supply. Starting bi-weekly and based on findings, service may be moved out as far as quarterly. The strainer should always be serviced immediately after a working fire or pumping operation. The control panel has these switches and gauges. CAFS on-off switch, to press the switch to the left to turn the system off. To press the switch to the right to turn the system on. The system will not restart if air pressure is above 30 psi. Note, the switch will not work unless the water pump is engaged. There are interlock safety switches to prevent the compressor from running, as water is needed to help cool the compressor during use. CAFS mode switch. Leave the mode switch in the auto position to auto-balance the CAFS pressure with the pump pressure. On older trucks, it might be labeled as foam, but it is actually in the auto-balancing position. Move the switch left to manually adjust the pressure with the fixed pressure regulator. Air pressure gauge. This gauge monitors the air pressure of the CAFS compressor. The reading should be balanced to the water pump pressure when in foam mode. CAFS oil temperature gauge. This gauge monitors the oil temperature in the CAFS system. The typical operating temperature is 165 degrees Fahrenheit to 210 degrees Fahrenheit. CAFS alarms. High oil temp. These alarms provide audible and visible warnings if oil temperatures reach 250 degrees Fahrenheit. The warnings consist of a red warning light, audio alarm, and a warning displayed on the multiplex. CAFS airflow meter. This meter monitors the CAFS airflow in standard cubic feet per minute, SCFM. Step 1. Engage the water pump and recirculate water. If equipped with a two-stage pump, volume mode should be used. Step 2. Ensure that all CAFS air discharge supply valves are in the off or closed position. Step 3. Turn the system on. Engage the foam proportioner and compressor. The CAFS should be in the foam auto mode. Step 4. Ramp the pump pressure up to 80 to 125 psi. 100 psi is common. The CAFS pressure should mirror the water pump pressure. Step 5. Slowly open the desired discharge all the way. Note, The air compressor's air pressure will automatically follow the pump pressure when in the foam mode. Step 6. The air is turned on to the discharge by using the switch we made sure was turned off in Step 2. The discharge will now be delivering compressed air foam. Step 7. Use the air and water flow meters to monitor the discharge's performance. Monitor the compressor's temperature, which should be between 165 and 210 degrees Fahrenheit. For puck with CAFS startup, ensure CAFS air switches are in the off position. Some units have a shared PTO for the generator and the CAFS, and will need to engage the generator PTO in order to run the compressor. These units will have a tag similar to the one shown below. Press the CAFS switch. The sequencing is such that it will automatically turn on the water pump and foam system. At the pump panel, open the tank to pump and recirculation line, ramp up the pressure, select the foam discharge, and open the valve after deploying the hose. After the discharge is charged, open the air valve. When stopping foam operations, perform the following. Close the air discharge valve. Disengage the air compressor. This may be left on, to blow lines out after Step 4. Disengage the foam proportioner. Continue to flow water through the discharge lines. Close the discharge valve. Take the water pump out of gear. Finally, open the manifold drains. Open all manifold drains after operation long enough to bleed the pressure. Strainer maintenance should start as a bi-weekly check. Water hydrants are different all over, so if you are not seeing a whole lot of debris at the 2-week checks, move it out to monthly. This can be moved out as far as quarterly, as long as there isn't too much debris in the strainer when the scheduled check comes around. Always check all inlet screen strainers after extended operations, or when flowing from a non-familiar water source. Inspect the following daily or after each use. Hydraulic oil in the tank, and the compressor oil level, air lines, oil lines, tubing. Each month, inspect the air filter, plumbing, water strainer, foam strainer, and exercise the system for 10 to 20 minutes if there is low usage. Inspect the drive line semi-annually. Biannually change the compressor oil and filter. The earliest uses of compressed air foam used a water-to-air ratio of 1:1, in terms of GPM and CFM. That ratio was driven by the fact that the earliest systems used a very poor agent, as far as foaming went. Later, the better foams made a drier foam, and for a time we liked it, due to the heavy viscous nature of the foam. We would have fires, however, nozzle personnel said that it puts out the fire, but it doesn't cool. The wetter foam still has the fast knockdown, but it also releases much more water to aid in secondary cooling. The water-to-air ratio of the 80s and early 90s came from the wildland-urban interface, and from tribal knowledge of the earliest CAFS systems. The ratio was 1:1, gallon per minute to CFM. In reality, anything that will let the stuff out of the end of the hose will work. At times only a shut-off gate is used. The ratio is now more like 2, or 2.5 to 1. The early mantra was that a shut-off gate and a smoothbore tip was needed. Since compressed air foam is essentially a finished product inside the hose, it needs only to be discharged from the end of the hose. We want a wetter foam. The wetter foam does the fast knockdown and also has foam solution available to penetrate and finish the cooling process. Larger bore tips, approaching the size of the hose, produce the smoothest, most unbroken stream of foam. The larger bore tips operate at low nozzle pressure, which results in the least breakup of the foam discharge and a dry foam. This type of foam is not used to fight structure fires, as the water content is too low. Water is needed to make steam for a rapid knockdown of a fire. smaller bore tips produce a more broken stream of foam. Note the feathering and expansion of the stream at the point of exit from the tip. The smaller bore tips operate at higher nozzle pressure, which results in the partial breakup of the foam discharge. The smaller tips are used to create a high-velocity fire stream of wet foam suitable for fire attack that behaves as a fog jet. Compressed air foam can be used through a combination stream nozzle. The combination stream nozzle will strip much of the air out of the foam bubble structure as the stream leaves the tip. The result will be a wet type of foam, which is suitable for fire attack. The nozzle will diminish the stream reach of the line from that of the straight bore tip, but the stream will still have adequate reach for interior attack operations. Introduction of compressed air foam into combination stream nozzles creates an aerated fog pattern with very fine division. The fine division of the stream makes it very effective in mop-up and attacking fires in wildland fuels such as grass. Because the hose line is filled with compressed air foam, it is extremely maneuverable due to its light weight. Crew fatigue is reduced. The airflow meter, when compared to the water flow meter, makes a good training tool to determine how far to open the water control handle to make different types of foam. A 2 to 2.5 to 1 ratio of water to air is a good starting point for most initial attacks. Example, a 1 3/4 inch hand line flowing approximately 100 GPM, at 50 CFM. Keep in mind, the airflow meter is only a guide. Operating different discharges at different rates makes the flow meter ineffective, as the water and air flow meters show the total being discharged. For initial attack, if the stream has good reach, it is foamy, looks wet, and has some kick, go with it. You have the flow meters to check the details, but get used to just opening the valves to a certain point at a given pump pressure and leaving things alone. So, what should a 2.5 inch line flow? Use one of these nozzles. Otherwise, you will end up somewhere you do not want to be. These are 1 3/8 inch bore. Get the water up to 200 to 250 gallons per minute. Here is an even better way. This is the Akron version. Task Force developed the first one called the Blitzfire. These can go to bigger bores, such as 1.5 inch. Get the water up to 300 or more GPM. The hose is light, so you can move one of these charged. But, do not try moving it while flowing. Once positioned, this monitor can be used as a breakdown point for headlines. It has a shut-off gate, and it is a 2.5 inch NST thread. It is important to note, in order for a CAFS system to deliver the proper range of foams, there are certain nozzles that are required. If compressed air foam is discharged through a fog or combination stream nozzle, the foam will be very wet. Such a nozzle strips much of the air from the foam as the foam exits the nozzle. Such nozzles work very well for mop-up and instances where wet foam is desired. When a thicker foam is desired, the operator must use a nozzle with a smooth straight bore. A straight bore nozzle does not strip as much air from the foam. The foam is more viscous because of the retained air, and is drier. Too small of a smooth bore will give a wet foam as it will strip air the same as the combination nozzles. Nozzles with a bore of 1 inch, on a 1.5 inch, or 1 3/4 inch hand line will yield a semi-wet foam that is good for initial attack. On hose lengths of up to 250 feet the pump pressure should be approximately 100 psi. The operator should adjust the discharge valve until approximately 100 gallons per minute is flowing. Nozzles with a bore of 1 1/4 inch to 1 3/8 inch on a 1.5 inch, or 1 3/4-inch hand line will yield a dry foam that is good for exposure protection. On hose lengths of up to 250 feet the pump pressure should be approximately 100 psi. The operator should adjust the discharge valve until approximately 30 to 50 gallons per minute of flow is displayed by the flow meter, if equipped, or open the water valve for wet foam. The air meter will read about 80 to 100 cfm of airflow. Note: a larger hose will not flow more water if it is limited by a small nozzle. Review the following list of common mistakes.